Hello everyone. In this session of CCNP ENCOR series, I'll discuss SD-WAN architecture. SD-WAN architecture consists of four main components. First one is SD-WAN edge device. Here if you see, this is one of the component, SD-WAN edge device. And it is part of the data plane. Then we have Vsmart controller, which is part of the control plane. Then we have Vmanage or Vmanage network management system, which is part of the management plane. And then we have Vbond orchestrator, which is part of the orchestration plane. And the last one is the optional one, Vanalytics. We'll go ahead and discuss about each of these components in detail. To start with, let's discuss about Vmanage NMS. Vmanage is a single pane of glass for managing the entire SD-WAN fabric. It is part of the, as I discussed, management plane of the SD-WAN system. It provides a graphical user interface for configuration, monitoring, and software updates and policy creations. It also offers, Vmanage also offers APIs for automation, making it a powerful tool for centralized management and control. Another component we have is Vbond. Vbond actually is the orchestrator of the SD-WAN solution. It is part of the orchestration plane of SD-WAN system and is the first point of contact for any WAN edge device joining the SD-WAN overlay. It actually authenticates and orchestrates connectivity between edge devices, Vmanage and Vsmart controllers. And the devices, they can locate the Vbond through, when you turn on the device, the devices can locate the Vbond through specific IP addresses or FQDNs, fully qualified domain names. And now you will wonder how this information is, this FQDN IP address information is provided to the device. There are few options, like you can receive it via plug and play, or zero touch provisioning, or bootstrap configuration, or manual configuration. Vbond actually, I would say, acts as a glue that binds the SD-WAN fabric together. Initially, when Vmanage will try to connect to Vbond and goes through an authentication process, what will happen is, like, for example, when a device comes on and when it knows about the IP or FQDN of the Vbond, it will try to authenticate itself with the Vbond. Not only WAN edge device, actually every device in SD-WAN architecture, like for example, controller device such as this will also authenticate with Vbond. Or if you take the Vsmart controller, they will all authenticate with Vbond. Now, once the authentication is successful, it will create after successful authentication, a DTLS tunnel is established with all. Like for example, with Vbond, managed device will form a DTLS tunnel. Once the DTLS tunnel is established, Vbond will provide the WAN edge connectivity details. It will provide WAN edge devices with connectivity details for Vsmart and Vmanage. So once this information is provided, it will tear the tunnel, and then what it will do is, like the WAN edge device will form a direct DTLS tunnel with controller for further communication. So this is how the Vbond works. This is just a high level overview, because we're not going to details of. So this was just a part of like how this Vbond, what are the main functions of the Vbond. So talking about functions, there are actually three major functions provided by Vbond orchestrators. It offers authentication, as I said, like it ensures only the authorized devices join the SD-WAN fabric using, and this authentication is possible by using certificates or RSA cryptography. Then another important feature is offered is NAT detection. Like It identifies if devices are behind NAT using something called stun mechanism. Then it also offers load balancing. Like if you have multiple controllers, it balances sessions to multiple Vsmart or Vmanage controllers for optimal performance. The other important component we have is Vsmart controller. The Vsmart controller is the brain of the SD-WAN solution, right? It is the brain of the SD-WAN solution. It is part of the control plane of the SD-WAN system. They are positioned as hub routers in the control plane topology, and all V-edge routers pair with the Vsmart controllers. I would say they are like BGP route reflectors, and they are responsible for learning all the routing information and then calculate the routing table and distribute it to the WAN edges. So the edge devices doesn't have to deal with all the calculation of the routing and all. All the things are done by the Vsmart controller, which is the brain. It uses actually OMP protocol to establish the neighborship, like overlay management protocol to establish neighborship with edge devices to form, over the secure DTLS tunnel. Because when you authenticate, after the authentication with Vbond, when you get all the information, you will form a DTLS tunnel, right? And over the DTLS tunnel, it will form this neighborship with edge devices. So OMP also runs between Vsmart and, it runs between actually Vsmart and WAN edge devices. Because the Vsmart has a complete picture of the network state, you are able to simplify the best path calculation. As I said, like the headache of calculating the best path and everything is done by the Vsmart controller, which will reduce the complexity of the entire network. Vsmart is also responsible for the implementation of control plane policies or centralized data policies, service chaining, and VPN technologies. Before, what was happening is, in traditional network, you have to go into each device and configure the policies. But here, the controller will do that work for you, and that will do it in an automated way. It will also handle the security and encryption of the fabric. Another component is SD-WAN edge device or WAN edge routers. SD-WAN edge devices are like physical or virtual devices that forward data traffic or that forward traffic across these WAN circuits. These devices actually represents the data plane of the SD-WAN system. They sit at the WAN edge and establish the network fabric and join the SD-WAN overlay. Like you can see here, they are sitting at the edge of the network. They connect branch locations, campuses, data centers, as I have shown here, or cloud providers. These devices support standard routing protocols like OSPF, EIGRP, BGP, along with the advanced SD-WAN features like QoS, ACLs, and routing policies. They automatically establish secure DTLS tunnel with, as I said, with smart controllers. And then for communication between devices, this you need to remember it, like between these devices, it forms a IPsec tunnel. To communication with the controller, it uses DTLS, but with this, between the devices, it forms the IPsec tunnel to ensure like communication across the WAN is secure. And WAN edge devices could be, these devices could be V-edge routers or Cisco XESD-WAN routers. Actually, the V-edge routers are legacy and no longer sold by Cisco. So Cisco encourages migration to C-edge routers. The Cisco IOS XE platform devices are actually referred to as C-edge routers. Another component we have is Vanalytics. Vanalytics is a optional but powerful component of the SD-WAN architecture. It provides advanced analytics and assurance by collecting data from all the devices in the SD-WAN fabric. With Vanalytics, you get real-time insights into application performance, network health, and security events. It helps in actually proactive troubleshooting, capacity planning, and the last one is optimizing user experience. These are some of the high-level overview of the different components in the SD-WAN architecture. That's it for this session. I hope this was informative for you. In my next session, I will discuss SD access. Thank you for watching. Please do like, comment, share, and subscribe. Also, if you are interested in any of my courses, you can check it out on my personal website. I'll share the link of this website in the description below. Thank you.